Mary, you should probably mute.
Welcome to Refrigerant Detection Systems 101. Please give us a minute as we are waiting for more participants to come to our webinar.
Okay, thank you everyone for joining us. My name is Helen Walter-Terranoni. I'm the Vice President of Regulatory Affairs at the Air Conditioning, Heating, and Refrigeration Institute. And we'd like to welcome you to this webinar on refrigerant detection systems, the basics. Mary, if you could go to the next slide. This is just our terms of use. So Mary, you can go on to the next slide. And just in case you don't know us, the Air Conditioning, Heating, and Refrigeration Institute represents more than 300 cooling and heating equipment manufacturers for residential, commercial, and industrial applications. You may have joined us for some of our previous webinars talking about the safe application of A2L refrigerants. The fundamental approach to the safety standards is to prevent ignition and combustion by controlling competent ignition sources and isolating them from flammable refrigerants. We're going to be talking here today about the specific aspect of sensors and detectors, but here's a list of other mitigating features in the safety standard. And we'll look at that in a house here now. So you can see there's a number of safety features that are in place in the safety standards. And today we'll be talking about that sensor and detection system. These slides will be available to all of you, as will the recorded webinar on our website. Let me introduce firstly Mary Koban, our Senior Director of Regulatory Affairs, who's just joined us at AHRI. She's got more than 25 years of experience in the chemical industry, with 15 years of that being in HVAC. She was at the forefront of the automotive safe transition to low GWP refrigerants. And she is on many of the relevant safety standards, as you see listed here. She's got an environmental engineering degree from Ohio University and a BS in physics and mathematics. And Mary will be guiding us through this webinar today. Thank you, Mary.
Thank you for that introduction, Helen. Thanks everyone for joining today. I'm pleased to note that this webinar is given by industry experts. I'll introduce our speaker for today's event in the order that they will present their slides. First, we'll hear from Carl Bengston, Technical Director at Sensair, North America Air and Gas Business Unit. Carl has 13 years with NDIR technology and product development for HVAC, DCV transmitters, and gas safety alarms. He holds an MSc Technology Management and Economics and a BScs Computer Science and Engineering, both from Chalmers University of Technology. Then we will hear from Ted Sunderland, who is Market Director Engineering Lead at Parker Hannifin Sporlan Division. Ted has 35 years HVACR control and sensing design and has authored 27 US patents in refrigeration control, sensing equipment and methods. He has an ASCS from St. Louis University and a BSCS from Colorado Technical University. He's a member of ASHRAE for 15 years and is on the Canina Working Group 14, concentrating on UL 603352-40 and chair of Annex LL Subcommittee. Next, we will hear from Bob Christensen, who is Senior Director, Business Development, Nevada Nano. Bob has 30+ years of business development, sales, and marketing leadership with a variety of technology companies, from large enterprises like Microsoft to new emerging startups delivering disruptive technologies and solutions. He has a BS degree in marketing with an engineering minor from Arizona State University. Then we will hear from Kaz Watanabe, CEO of FIGARO USA. Kaz has 25 years of experience in gas sensor field working for FIGARO. Kaz has a Master's of Engineering from AHRI University. He is on the US tag to IEC 61D, also on IEC 60335-2-40, working on the 7th edition, and is also a member of Canina Working Group 14 on UL 60335-2-40. And our final speaker is also another expert in the field, Gary Mouse, Senior Mechanical Design Engineer, Industrial Products Division of Sensata Technologies. Gary has 30 years experience, sensors and controls, design and manufacturing, serving critical needs of multiple industries. He has a BSME, University of Massachusetts. He also has SME, Control Atmosphere Analysis and Control Switching Technology. He is also a Six Sigma black belt. So now I'd like to go over the agenda that our experts are going to follow today. We're going to look at refrigerants types and properties. Then we're going to go over how refrigerant concentration and leaks impact ignition. Then we're going to go over the definition of refrigerant detection systems, how the equipment and installation standards fit together, the typical RDS components, RDS requirements under UL 60335-2-40, Annex LL, and then some of your commonly asked questions regarding RDS systems. So first, before we dive into our topic today, I'd like to give a brief overview of refrigerants and the different safety classifications that we see, right? So first, toxicity is divided into two parts, A or B, with A being lower toxicity and while B is higher toxicity. And then flammability is divided into four groups, 1, 2L, 2, or 3, based on ASTM E681 testing. Class 1 refrigerants are sometimes called non-flammable, but that means they are practically non-flammable and they don't exhibit flame propagation when they're ignited. Class 2L, 2, and 3 all exhibit flame propagation when ignited. What's really important and what we'll be spending a lot of time on today are the A2L refrigerants, those that are a new class and what we call mildly flammable or low flammability refrigerants. Those have low burning velocity, lower flammability level, meaning a lot of refrigerant needs to leak out. They have a high minimum ignition energy, meaning it's hard to ignite them and get those to sustain a flame. And they also are, once they are ignited, or if they are ignited, they have a low energy release and or low pressure rise. So that's really what we're going to be spending time on today are these refrigerants. And we're going to look at leaked refrigerants and what needs to happen to get refrigerant ignition. So here I have a little diagram that we're going to be seeing throughout the presentation. And what I want to share with you right now is the refrigerant concentration is on the left side and time is on the right-hand side, or on the x-axis. So really what I want you to see is what needs to happen to get refrigerant to ignite. First, you need to have a catastrophic leak for the refrigerant to get above the LFL. So a lot of refrigerant has to leak out. And you need to have a viable ignition source at the same time and at the same location as the LFL. And through our previous project, AHRI 8017, we found that there are very few energy sources that are able to be a viable ignition source for the A2L refrigerants. Now, again, let's look at, I'm just going to give you a brief snapshot of today's topic. We're going to be talking about the RDS, or refrigerant detection system, and how we're going to stay at a lower level and stay below this LFL, and what we're going to do to achieve that, and how this is going to go on. So now let me hand off to our first speaker, Carl.
Right. Hello, everyone. Thank you, Mary. Thank you, Helen. So I'm Carl. I'm with Sensair. And as those last two very green slides was showing you, the purpose of the RDS is really to prevent a hazardous situation to occur when there's a refrigerant leak by essentially engaging a mitigation action and creating a dispersion, a dilution, a displacement of that pooled refrigerant gas. So the RDS, and I'm going to use the terminology RDS quite often here instead of the full refrigerant detection system, is really like a system or a portion of a larger combination system. And it's going to use stationary devices. I'm going to touch upon what that actually means a bit later on. But the purpose is to detect the presence of this specific refrigerant and specific threshold concentration to signal to initiate one or more mitigation actions by the HVAC equipment. And also, just to clarify, self-contained alarm devices typically found in maybe machine rooms, I mean, while they are detecting refrigerants, yes, they're not classified as an RDS. So we really want to focus on the RDS per the UL definition of how it is interacting with the HVAC equipment itself. And so the term devices that I touched upon, I mean, to make it fair for Sensair and all my other industry colleagues for this presentation, it is essentially the guts of the sensing technology that we use to detect that leaked refrigerants. So Mary, next slide, please. And in addition, before we deep dive into this, the RDSs that we're talking about, the refrigerant detection systems, I mean, we put that into the focus of how it is integrated or how it is working within the HVAC equipment. We are not going to focus within this forum for how the HVAC equipment that is charged with an A2L gas impacts, say, within and around buildings for safety or premises facilities overall. We're going to focus on the UL part and the annex LL, MM, and GG parts that kind of create this safety operational of the HVAC equipment. So Mary, next slide. So this is a very conceptual picture of an RDS. And again, bear with me that we're kind of trying to stay as generic as possible. But the RDS is then the dashed box with these other components inside. And if we start with the sensing element, this kind of yellow box, that would be the actual physical detecting signal, whether that is an element that reacts in presence of the refrigerant gas, or it's an intermediary media like infrared light that is, being impacted by the presence of a refrigerant gas. That is the core detecting element. And that one is being converting its detection into the refrigerant sensor part, which is then computational part, if you may, or kind of converting that physical signal into a concentration or something that can be reacted upon once it passes the threshold. So here's kind of where it gets more tricky, because depending on the HVAC equipment, there may be one or several of these sensing parts, the black box, which is also this stationary device in the previous definition. So there can be multiple of them. And also the specific communication or the interfaces for how these RDSs actually talk to the HVAC equipment is of course also specific, or it depends on the HVAC OEM manufacturer. So the RDS systems, even though this is the kind of narrow generic definition, can come with additional features and different communication interfaces. So Mary, next slide, please. So now when we kind of define that, what the generic RDS looks like, we know that it may look a bit different depending on whether or not it is merged with what we would call a mitigation controller that would be the actual driver and enabler of the mitigation actions. But the RDS, the point of what it's going to do is signal when you have an A2L refrigerant leak passing that predefined threshold. And again, to kind of go into why you would need multiple ones, the Annex MM and the size of the actual HVAC equipment and how it is designed and where actually you might have the pooling of leaked refrigerants can require multiple ones. And so, sorry, Mary, go back, please. So yeah, so in terms of what we will talk more about in this presentation, I mean, is how and where and sort of the ruggedness of these RDSs to ensure safe operation of the HVAC system. If you look at the conceptual picture on the right, kind of the wheres and why the RDS is in this kind of conceptual picture that I took from energy.gov for a outdoor condenser unit and indoor evaporator coils. So Mary, next slide, please. So again, to summarize and zoom out even more, now that we know that we're talking about the RDSs and how that interoperates with the HVAC equipment according to the UL, and not so much the building or the implied ASHRAE standards, because that's a completely different forum. I'm going to hand it over to, well, my industry colleague, Ted, to go through the Annex LL. Thank you.
Thank you, Carl, and thank you everyone for attending today and your interest in this webinar. The A2L Refrigerant Detection System, or RDS, and I will follow Carl's suit on that one. It's a big mouthful and my mouth gets dry when I'm talking. It's going to be factory installed, and the installation of the sensor will be in a location specified by the equipment manufacturer for the equipment into which it's installed. And that's kind of a carry-on of what Carl alluded to, is the size of the equipment, configuration of coils, the installation itself. All these things affect where the most opportune place for the sensor to be in order to ensure the safety of the system, that we detect the refrigerant concentration level much before it becomes a hazard. The equipment is tested in accordance with Annex MM of UL 60335-2-40 to demonstrate that the sensor adequately detects the leaked refrigerant in the location specified by the equipment manufacturer. The illustration on the slide you're looking at is intended for reference and is not to indicate a sole or preferred location of the sensor, just merely to give some idea of where it may be in the system. As I mentioned, the configuration of the equipment and the required operation of the RDS, we'll talk a little bit about more. In further sections of this annex will drive the final determination of the sensor location. Next slide, please. Sensing technologies suitable for this application are quite ubiquitous in a variety of sensing applications. Some have been used in gas sensing applications for 40 plus years. So nothing new on the sensing side. Newer, there are some new things out there and they're quite exciting. Technologies remain the same, whether it be 40 years ago or next week. The sensor is just merely tuned for being responsive to an A2L refrigerant gas rather than another target gas in another application. This annex also provides the regulatory requirements for refrigerant detection systems for A2L refrigerants. As was presented earlier by Mary, there's a large safety factor between the refrigerant concentration at which the RDS must respond and the concentration at which the A2L refrigerant vapor may pose a hazard and reach a lower flammability level. The maximum concentration threshold at which the RDS must initiate mitigating actions is defined in the UL standard and NXLL. The actual threshold for detection in the application can be less than that defined as the maximum, but no greater. This provides assurance that an A2L refrigerant leak will be detected at concentrations well below those that would pose a hazardous condition. Having detected the presence of the leaked A2L refrigerant, the RDS will initiate mitigating actions that are defined in a further annex of 60335-2-40, being Annex GG. Mitigating action, as Carl mentioned, is intended to dilute the refrigerant concentration and maintain a concentration well below the flammability limit, and this will prevent sorry. I looked to the left and missed to the right. As we've alluded to and spoke to before, and it's becoming apparent, the time required for the RDS to sense and react to the presence of the leaked A2L refrigerant in conjunction with the accuracy of the RDS is paramount in effectively mitigating a potentially hazardous condition. NXLL.3 prescribes the requirements for achieving this. Additionally, LL3 requires providing continuous operation in accordance with the required response time and accuracy when exposed to the environmental conditions present in the equipment, conditions such as humidity. In an HVAC application, this can often be 100% condensing in some locations. Temperature extremes. These systems will be exposed to heating and cooling cycles, so they'll see cold as well as heat from a electric or gas-fired heating system, and also pressure, which plays a part whether our application is in Death Valley or in Leadville, Colorado. This is all to ensure that the RDS is fully functional in all expected and anticipated and beyond anticipated environmental conditions and in application locations. The RDS is installed with a preset detection threshold and is calibrated for the refrigerant listed on the equipment nameplate. A pre-calibrated and installed RDS not only will provide the safe operation of the A2L charged HVAC equipment, but also prevents false nuisance trips from having been supplied with too low of a detection threshold value. A faulted or failed sensor is required to provide a signal to initiate mitigation action since the presence of a leaked refrigerant can no longer be detected and remains unknown. This to err on the side of safety. Next slide, please, Mary. Akin to operation under specified environmental conditions, the RDS is subjected to vibration testing to ensure its ability to reliably operate when exposed to vibration that would occur when mounted in the system. The RDS has one or more facets of its functions under software control. The software is required to initiate and perform a sensor self-test at least once per hour. If a failure of the RDS is detected, the mitigation action is initiated. The sensor is additionally labeled according to the requirements of Annex LL. This provides the information fully defining the intended refrigerant and the equipment manufacturer of the sensing device and RDS system. Next slide, please, Mary. My favorite green slide. Annex LL of 60335-2-40 provides the requirements and tests needed to keep us in the green. And now,
Handing this off to Bob.
thank you. Yes, to my friend
Thanks,
Bob. Thank you,
Thanks,
Mary.
Mary. Thanks, Ted. Good afternoon, everyone. Thanks for joining us today. So what does the RDS actually do? The hope is that the RDS is never needed to detect potentially harmful refrigerant leak. However, the RDS is actively and continually monitoring for the presence of refrigerant. In addition, at least once an hour, the RDS confirms its own state of readiness and signals the readiness as well as performing within specification to the control board if it's not functioning properly. Other than that, the RDS sits quietly, waiting to signal should a potentially harmful refrigerant event be present. Next slide, please, Mary. So if you're a firefighter or consumer, for that matter, you should be aware of basic operating principles of the RDS and how it compares to other sensing safety devices. The RDS employs what is called or referred to as active mitigation methodology. The refrigeration detection system will detect leaking refrigerant, and the HVAC equipment will take some sort of mitigating action, whether that's turning on a fan, closing a valve, as well as an alarm. But the main objective is to continually monitor for potentially harmful leaks at the desired set points, and dependent on the set points are dependent upon the amount of the amount of refrigerant that's present, as well as the volume within the area that it's installed in. Comparing that to passive mitigation devices, commonly known as smoke detectors or carbon monoxide detectors, that are passive in that they'll sound an alarm, but require a human to perform the mitigating action, which could be leaving a property, putting on PPE, and addressing the situation. Next slide, please, Mary. So an important question for these embedded RDS systems is, what's the expected lifetime of a system? There's various technologies, various sensing technologies, various RDS solutions, and then even locations within a unit. All that will be determined by the HVAC OEMs. However, the RDS solutions are anticipated to last 10 to 15 or more years. If the RDS comes with a predetermined lifetime, the 2-40 Annex LL-7 requirement that Ted just reviewed, requires that it have a self-indicated end of life or approaching end of life. After reaching the expiration date, obviously the sensors would need to be replaced by OEM approved parts. Next slide, thank you. So what's required to maintain and service the RDS? The RDS systems are extensively tested to UL 2-40, specifically the Annex LL and Annex MM, which Ted went through and are still currently under review for this specific application. But when servicing a unit, care should be taken to keep these components in good working order. Please avoid direct spraying of the sensor when cleaning the coils, and also avoid positioning the sensors or tampering with the sensors while servicing the unit. So here's our favorite slide that we keep adding on to section by section. So at the bottom of this illustration, we've overlaid the RDS self-test signal that you see over time or periodically to ensure that the system is operating with normal specifications. So with that, I'll hand it over to Mr. Watanabe from FIGARO, who will go into more details about failure modes and leak mitigation.
Thank you, Bob. Hello, everyone. So first off, let me explain what happens when the RDS fails. In the event of RDS failure, fan or blower runs all the time as a mitigation action. HVAC continue with safe operation mode until RDS is replaced. And what would happen when refrigerant leak is detected? In that case, HVAC may continue limited operation safely until shutdown or repair. Okay, let's look at more in detail at the next slide about the operation when refrigerant leak occurs. When refrigerant leak occurs, fan or blower runs continuously as long as refrigerant concentration is above threshold, and HVAC compressor will be shut down. If leak is not below threshold, heaters and other devices are turned off. If leak becomes below threshold, after 5 minutes of fan or blower activation, HVAC compressor will be allowed to run. Detailed requirements for ventilation are described in Annex GG. Next slide, please. So what type of training will there be regarding RDS? Training of RDS will be provided by the OEMs. Actually, Annex DD described all the requirements for installation, service, maintenance, and repair. Training or handling precautions of refrigerant sensors will be provided by the sensor manufacturers to the OEMs. Next slide, please. So why is it important not to bypass or turn off the RDS? Because the refrigerant sensor play an important role in preventing leaked refrigerant from accumulating. Actually, OEMs are designing systems that will automatically enter mitigation if the sensor is bypassed or disabled. Therefore, it is quite important to ensure that the RDS is not disabled. Next slide, please. So I hope that you understand that HVAC safe operation by utilizing RDS, detecting refrigerant leak, and initiating mitigation. Okay, can you switch to next presenter, Gary?
Yeah, thank you, Kaz. So the next question that we have here is how many sensors will be used in an HVAC system? And that's actually a very good question. It's not really that easy to answer. So I'll do my best here. Basically, the number of sensors in any given system will depend on the size and the configuration of the system. Sorry, it's not a more definitive answer, but in some cases, as per UL 60335-2-40, if the system is small enough, it actually won't have any RDS at all. In the range of approximately a 4-pound or less charge of refrigerant, the UL standard doesn't require an RDS. When systems get a little bit larger than that and they require a larger refrigerant charge, obviously in residential and commercial applications, an RDS will become necessary. It's possible that the size of the system only requires one sensor. If it's small enough but large enough to require an RDS, it's possible that only one sensor is necessary. But as the systems get larger and larger, proximity to possible leak points would become an issue. So more and more sensors would be necessary to be deployed throughout the system. Another issue that's associated with the number of sensors, if you go back, please, is the fact that the larger systems, refrigerant could potentially pool in different areas of the system. So that's another concern or another care about that's addressed in the UL standard. So basically, it will be the OEMs that, for each of their systems, will be determining how many sensors are actually needed in a particular system. Okay, next slide, please. All right, well, the sensors need to be located in a specific location within the HVAC system. Absolutely, yes. To ensure that detection and mitigation in the event of a refrigerant leak, the OEMs will determine the required sensor locations. Okay, if in the event there's only one sensor needed, then they'll define the actual location. If there's multiple sensors needed, again, they will define the location where each sensor needs to go. Requirements on how to test each HVAC system are defined in Annex MM. Each system has to demonstrate compliance in order to be put out into the field. And so this test is what the OEMs are using to ensure that their system, the sensor locations and the number of sensors puts them in compliance. For systems that have multiple possible configurations, so maybe the configuration of the HVAC system can change in the field based on the installation. The sensor location for each possible configuration of that particular system, again, will be determined by testing by the OEMs as defined in Annex MM. In every case, it's required that the sensor and locations selected by the OEM for a given system can detect refrigerant within a defined time. This is so that the RDS can initiate mitigation well before the concentrations increase to a potentially unsafe level. And to confirm the OEM system are designed correctly and are in compliance with the UL standards, a nationally recognized test lab will be used to confirm each system. Next slide, please. All right, will the RDS be capable of working with multiple refrigerants or HVAC systems? The short answer is no. Okay, each RDS is designed and certified for a specific refrigerant in a specific piece of equipment or HVAC system to ensure that it operates or functions properly. To avoid the potential for an RDS to be incorrectly configured, possibly for incorrect refrigerant, for example, or other settings that need to be specified or are specific to a particular system, the RDS will intentionally be non-configurable in the field. So in the event of any portion of the RDS requires field service, maybe due to a failure of an RDS, the UL standard 60335-2-40 defines that replacement has to be with original equipment parts. And that's the only option. There is no other option. So again, the RDSs are matched and tested to specific HVAC systems by the OEMs. So deviating from what's been defined to something that's close is not an option. The only option is to replace with original equipment. Next slide, please. So in summary, a lot of information here. I'm just going to summarize a little bit of it here into some primary bullets. First off, we have 5 different sensor manufacturers represented here, each using well-known sensing technologies in solutions that are used in RDSs. And we're sharing what we know about the safe operation of the A2Ls and HVAC systems. From an installation perspective, each system in which an A2L refrigerant is used, the system design is required to be tested by a nationally recognized test lab, so a third-party test lab, to ensure it meets the use and installation requirements of Annex LL and Annex MM of the UL standard. In addition, requirements defined in ASHRAE 15 must also be met to confirm, not confirm, but ensure appropriate safe building installation. From an RDS use perspective, some key points to touch on are that once a system is installed, the RDS continuously monitors for the presence of refrigerant 24/7. The whole time the RDS is in operation, it confirms its own state of readiness once an hour. And that makes sure that it's operating correctly. And if found to be operating incorrectly, it takes action if any issue is found. And that action being the activation of mitigation to ensure that a safe condition below the lower flammability limit is maintained. In the event of a refrigerant leak, mitigation actions are taken very early with a large factor of safety to ensure levels of concentration are kept safely below the low flammability limit. Next slide, please. Okay, and everybody's favorite slide. We all get to have a chance with it. So again, I think you've seen this slide plenty. It has a very good message. I'm hoping now that we've discussed, the things that we've discussed here today makes the message of this image clear. And a couple of key points to share is, or to go over, is that the UL standard has defined to ensure is defined to ensure safe use of the A2L refrigerants. It also illustrates the RDS will ensure safe handling of a leak in the event that it ever occurs. Okay, again, this to be risk being repetitive. This is achieved by the RDS continuously monitoring a single or multiple sensors within the HVAC system, and that will depend on the size of the system. Okay, and it's always looking for the presence of refrigerant. Due to the work of the OEMs to ensure the proper number and the proper location of RDS of the RDS sensors in each system, mitigation actions, whether they occur due to a leak or if they occur due to a system fault of some sort, will keep the concentration of A2L refrigerant well below the lower flammability limit. So Mary, that's all I had.
Thank you. Thank you very much, Gary. Again, really just great presentation, 5 industry experts. What more can you ask for? Just to recap how this all fits together. Again, the RDS is installed in the piece of equipment. The equipment is tested per UL 60335-2-40. That's installed in the house or the commercial building according to ASHRAE 15.2 or ASHRAE 15. Really, it all ties together, and we talked a lot, and we tried to bring it through so it could be really clear to everyone. The green, what we're looking at is we're always going to be at that safe level with the RDS system inside the equipment. Again, just want to reiterate what a great presentation the guys had here. And what are some important things to remember? Health and safety go hand in hand. Low GWP refrigerants are a step towards a healthier environment, reducing greenhouse gas emissions and global warming. The RDS ensures a safe environment is maintained in parallel in these pieces of equipment. And with this in mind, in the event any portion of the RDS requires replacement, we also saw if there was the unlikely event of a possible failure of the RDS, everything will be in the safe mode. Again, it's critical to replace components with those defined by the OEMs and use the procedures and outlines given by the OEMs in their instruction manuals. Again, just wanted to recap those points. I think we have some time for some questions, and I'd like to go to a couple of the questions that were asked early on. I think there was one that we were saying, Carl said he could answer the first question if he would, and then I was thinking Carl answer the first question, and then we'll go to the next question. Carl, if you would. Oops, sorry.
Right, thank you, Mary. So I think it was Edwin who asked about the lubricants that are also pumped around in the coils, and yes, within the Annex LL, you have both kind of the test table of disturbance gases to ensure that your RDS system or your sensing system is not implicated by those disturbance gases or by poisoning. But of course, you also have the actual testing requirement for the sprays, which is going to be part of this nationally recognized testing laboratory methodology. So we're already building the RDSs to be immune to this. So I hope that answered the question. Yeah, I guess Edwin, you can't reply, but I hope that answered the question. So maybe Mary, we take the next one.
Yes, I was going to ask for Ted to do the next question, if he would, on self-test.
I'd be glad to, especially since Roy asked the question. And it's a really short answer. How does the self-test work? A lot harder than I do. Don't get any feedback in a webinar. At a minimum, in the standard, the self-test will detect an open, shorted, or missing sensor. At a minimum, and that's as a standard would be written. Additionally, some other things can be added, should be added, will be added by sensor manufacturers. Will go above and beyond the standards where necessary for safety and to meet OEM requirements. Such things as an out of range reading, an under range reading, unstable readings. There's a myriad of electronic circuitry that can be tested via software. So the extent of the self-test, at a minimum, missing, shorted, disconnected sensor, and then built upon that as the requirements are driven through the OEMs and through development standard, or standards development, I'm sorry. That's my response, Mary.
Yeah, sorry, I'm having a tiny bit of difficulty here on my end. I think we had a question on the RDS in the field with the help of a field kit and installed, or is it mandatory that the RDS has to be factory installed? Bob, I think you said you were able to answer that one, please.
Sure. At this time, it will have to be required, be installed at the factory. That is a requirement. There is no field kit or aftermarket installation.
Okay, I think we probably have time for one or two more questions. I think there was a question out there that asked whether the RDS would be in the inside of the house or in the outside of the house. Gary, I didn't know if you wanted to answer that one. Where's the most likely place where we would see the RDS?
Sorry, Mary, I was muted. Yeah, the most likely place is where it is most likely to leak, or where it is most likely to pool. So I believe the answer to that is best defined by the OEMs, but I can take a swag at my opinion would be, it would be in the area that is best to protect human life. So if that's in the home, then obviously that would be where the RDS would be located.
Okay, great. I think we've answered most of the questions that I'm seeing. There may have been one other question that we talked about, the RDS required mitigation level been specified. Ted, sorry to give you a second one, but I think that was in your area on Annex LL. I didn't know if you wanted to answer that one.
I'd be glad to. I speak better answering questions than I do trying to present. So this is a chance for me to make up for my poor presentation. What was the question again?
Has the RDS mitigation level been specified or established? That was the main focus of it.
Sure. I'm sorry about that. As the question was stated, currently the standard states a 25% LFL or below. And I just wanted to expand on that just a little bit. And the or below covers if we're having a leak event and refrigerant begins to pool, the standard through Annex MM and GG give tests that prescribe where the most biggest leak event may occur that causes most likely for creating a hazard. That may not necessarily be where the sensor is located. And in order to compensate for that, by lowering that detection threshold, you may be seeing 25% LFL in this area and only 19% in this area. And with the timing in mind as well, these are diffusion sensors. They rely on the diffusion mechanism to get the gas inside, that trigger threshold may be set lower than 25% to ensure safe operation.
Great.
Long answer, short question.
No, perfect. I think we had one other question on dust and accumulation of dust and affecting sensors. And I think, Carl, you already answered that, but just to recap, if you could go and answer that one again, please, and touch on that.
Well, sure. I guess was related or similar question to the oil spray, which is, of course, something that the sensors have to deal with over the expected lifetime of the sensor. So I'm not sure if there's anything in addition. I mean, you could go into a lot of depth answering this question, like what happens if you have dust ingress, how can you prevent it in terms of particle filters and so on and so forth. But essentially the quick reply would be that the sensor needs to deal with it. And we have to design sensors that are capable of operating in this environment to deal with it during the extended or expected lifetime of the sensor, of the RDS.
Great. I think that's answered most of the questions. I think there might have been one or two questions that may have slipped in here that I may not have seen. I think there was one let me just go back, I'm checking. I think we've got all of them. There was one that asked about the typical charge size, the typical amount of refrigerant in a home system. And I think that's based on tonnage. I don't know, folks, this is folks who are dealing with the refrigerant detection system. I don't know if folks here have that answer because this is really on the detection system and staying below that safe level. Does anyone have that that value of amount of refrigerant per ton, refrigerating ton?
Well, I'll take a stab at it, Mary.
Sure, thank you, Gary.
At least I'll give you my input. Yeah, it's not an easy answer because systems vary so greatly. So there is no definitive answer to how much refrigerant is used per ton of compression. So it depends on the size of the area that's being affected or treated. So the UL standard, I guess the best answer I could give you is the UL standard has the methodology in which you would go through to determine the amount of refrigerant that would be used in any particular system. So that's probably the best answer that I can provide. The refrigerant quantity that was used in this presentation was, based on a minimum room size for a minimum system size, and how that would work out to the amount of refrigerant necessary. So hopefully that answers the question at least a little bit.
Yep, and I had one that came in to me before the presentations began. This one is for you, Kaz. Just to reiterate or clarify again, we were asked the RDS, if there is a failure of the RDS or a failure or a leak in the system, the RDS takes action. Can you reconfirm that the RDS takes action to run in a safe mode. Kaz, maybe you're
Hi,
on
this is
mute.
Kaz. Yeah, sorry. Yeah, definitely. So when RDS fails, so fan or blower run all the time. So it works with safe operation.
And you can reconfirm that also holds for if there is a refrigerant leak, right?
Right. If there is a refrigerant leak, HVAC may continue limited operation safely until shutdown or repair.
Great. Okay, and I think that was all we had time for today. I will take any of the extra questions and we'll write them down, and we'll have our panelists send the responses out to you. The slides will be posted on the AHRI website, and we appreciate all of you coming today, and we appreciate your engagement and your questions. We are also looking for other topics that you'd like to see and hear about at AHRI, so please send me a list of any items you would like to hear more about. And again, thank you to all of you who came, and thank you again to our speakers today.